Welcome everyone to the December 2021 webinar for the Esri State and Local Connect webinar series. Thank you everyone for taking the time out of your day and spending some 45 minutes with us. Today we are talking about a deep dive into imagery capabilities for state and local government. And we're going to talk about kind of the imagery capabilities that are available to you as state and local government professionals, as well as some places that you might be able to find some imagery data that's ready to go and you can bring into your work. So this series was started for state and local governments to kind of share ideas and to really highlight some of the key capabilities that you guys can do with GIS. So we're here every month. So this is the December one on imagery. So thank you again. And just a bit of housekeeping. So we will be monitoring questions throughout. So feel free to go to the GoToWebinars question pane and feel free to type in questions and I'll be monitoring them and I'll save some time for our presenters at the end so that we can get to them. The other thing is this is being recorded and everyone who's registered will get a recording about a week from today. So look out for that and you can revisit or share with colleagues. And so with that, I want to go ahead and introduce Chase Fisher and Nicole Grams. They're from our St. Louis regional office. So I'll let them introduce themselves and take it away.
All right, thank you, Shannon. So hello, and welcome again to December Esri State and Local Connect. I'm Chase Fisher. I'm a solution engineer for state and local government. I spent 14 years in city and county government, GIS administration, and I'm a FAA certified remote pilot.
And hi, I'm Nicole Grams, also a solution engineer. Before Esri, I worked for less than 14 years in central GIS and emergency management and 911 for county government.
We're both out of the St. Louis regional office, and this month, like Shannon said, we're going to take a deep dive into imagery, particularly the capabilities within state and local government. So first off, I just want to say that the work you've been doing is extraordinary in its breadth and magnitude. It's addressing virtually every big issue that our world is facing, from energy to environment to modernizing cities to just making sure city and state government run. You're changing how we make decisions. Some of you are working in environmental management, some in animal conservation, others in road management and DOT work. Some of you may be assessing land records or property boundaries, and without you, I'd never know where to put my fence up. Or maybe you're tasked with planning how a city should grow. Maybe your job's just to keep us safe or to help out when nature takes its toll, like we've seen with the recent tornado outbreaks across the Midwest. Or maybe you're just tasked with keeping the lights on and making sure the water at the sink keeps clean and flowing. No matter where you're at in state and local government, imagery and remote sensing are increasingly benefiting GIS workflows across these and many more areas. These imagery products are full of information and insight, and ArcGIS can help you extract it. Whether it's drone, aerial, or satellite imagery, remote sensing and data are opening up new frontiers in every facet of life, enabling our ability to understand the planet and the problems we face on a daily basis. Utilizing GIS tools, we can not only look at these massive data sets, we can also put them to work by using powerful mapping, geospatial analysis, and geospatial artificial intelligence workflows. Today, Nicole and I are going to cover a little bit from each of the following categories of ArcGIS imagery capabilities and how you can benefit from using them within state and local government. First off, management. How can you effectively secure, stream your imagery, whether it's raster data collections or whatsoever, and have it easily accessible internally and externally? Content. What do I mean by content? Esri provides the largest online collection of imagery, terrain, and geospatial information layers. Analysis. Using ArcGIS to extract information from imagery like land cover classifications, objects, and features, as well as change detection. And mapping. Being able to create real-world depictions of imagery, such as orthomosaics, digital elevation models, 3D meshes, and topographic maps. And with that, let's start our dive. Our first section, ArcGIS Image, Esri's full solution for imagery hosting and analysis. beginning with an overview of the ArcGIS Image product suite. These products enable imagery capabilities within ArcGIS. For the desktop product, we have ArcGIS Image Analyst for ArcGIS Pro. ArcGIS Pro provides a solid foundation for imagery capabilities, with tools for imagery management, visualization, and analysis. Imagery Analyst extends the use of Pro with advanced tools for image interpretation, exploitation, and geospatial analysis. For those of you with an enterprise environment, we have ArcGIS Image Server, which provides a scalable way to host, analyze, and stream massive collections of imagery using your own infrastructure. You can customize your deployment to fit your existing infrastructure, comply with regulations, and support mission-critical workflows using ArcGIS Image Server. For the software as a service or SaaS environment, we have ArcGIS Image for ArcGIS Online. This offering brings these capabilities to a hosted environment, allowing users to focus on the imagery and not the infrastructure needed to host it. ArcGIS Image for ArcGIS Online is Esri's complete software as a service for leveraging imagery services to support your work. It allows you to host, analyze, and stream imagery and raster collections in ArcGIS. So you might be wondering, how does state and local government benefit from using ArcGIS Image Online? By using tools that help you make the most of your imagery, enabling to be accessible across your whole organization, and giving you the flexibility to host and stream imagery in specific ways that best suit your workflows. Whether you're serving imagery of a newly constructed subdivision or the whole city, looking at post-event imagery, orthomosaics, or even multi-dimensional rasters. You can publish imagery as intelligent tile services for fast performance. A tiled imagery retains pixel information, so the users can perform client-side interactive analysis and apply enhancements to the imagery. Or you could use a dynamic imagery. This dynamic imagery service offers on-the-fly processing, dynamic mosaiking, and dynamic mosaicing. Together, these options let you seamlessly integrate imagery in a variety of applications and workflows. And in addition, you have full control over who has permission to upload, publish, access, and consume that imagery. With ArcGIS Image Online, you don't need to worry about infrastructure management. Instead, you just work with the imagery in a high-performance, secure, and scalable SaaS. This cloud environment that Esri manages, we take care of the infrastructure for you. Because ArcGIS Image is available in ArcGIS Online, you get the logging and other advanced reports that help you keep up with your organization's imagery-related activities, but you also can integrate with your organization's specific logins. ArcGIS Image Online simplifies image management by making it easy to publish and manage your imagery and raster collections. You can upload a variety of types and formats like orthomosaics, satellite scenes, aerial imageries, elevation, bathymetry, and even drone data. The metadata for these images is preserved, allowing users to access relevant details about the imagery. ArcGIS Image provides a simple web experience for uploading and publishing the imagery in just a few simple steps. This means publishing can be accessible to everyone in the organization that needs it. With ArcGIS Image Online, you can process imagery at scale using powerful interpretation, image analysts, and raster analytics workflows in the cloud. This helps you make use of your imagery to gain situational awareness, understand, extract insights, and support decision-making. You can apply analytics through intuitive web experience by using tools in Pro, or use our rich Python API to develop custom raster function chains and machine learning workflows. Once you finish your analysis, you can use that resulting layer for further analysis and incorporate it in custom web maps, apps, dashboards, reports, or even story maps. All this is powered by our elastic and resilient ArcGIS Online cloud environment, so you can do the image processing at scale without needing to acquire and manage the infrastructure. ArcGIS Image Online helps you save time as well on image processing and analytical tasks. Because this analysis is performed in the elastic cloud, processing scales effortlessly, and the tasks that used to take days or hours can be done much faster. It helps you meet the demands of your customers and complete projects in a timely manner. With ArcGIS Image Online, you only pay for what you use. You don't need to pay to maintain your own infrastructure because, like I said, Esri manages that software in the cloud and the resources on your behalf. And when you host the imagery in ArcGIS Image Online, you only pay a fixed price to store the imagery. Then you can access the imagery at no additional cost. In addition, you can allocate budgets to your users and estimate the charges for analysis tasks before they're performed, helping you control the cost. Now that we've described how ArcGIS Image Online helps you leverage your imagery, let's talk about how it works. Creating powerful imagery service in ArcGIS Online is simple as these four easy steps. Step 1, upload your imagery to ArcGIS Online. All you need to do is navigate to the My Content tab in ArcGIS Online under New Items and choose an imagery layer. Step 2, select the type of imagery service you want, tiled or dynamic. Like I said, tiled imagery layers serve original pixel values for client-side visualization and processing, and dynamic imagery layers provide on-the-fly processing and virtual mosaicing. Both layers can be used as inputs into raster analysis. Step 3 is to apply analytical and raster templates to transform your raw imagery into useful information products. We'll talk about these capabilities a little bit more in detail in a few minutes. And step 4 is to decide who will have permission to access the new image service and stream your imagery to those users. You can use role-based permissions in ArcGIS Online to define the individuals and groups that you want to access the imagery, or stream the imagery to the entire organization. Now let's take a quick glimpse at just how easy it is to use the software by stepping through a quick demonstration showing how to upload the data. To begin this workflow, all I need to do is log into ArcGIS Online. Now that I've logged in, let's look at the settings for my account. In order to leverage the capabilities of ArcGIS Image for ArcGIS Online, your organization administrator must assign you a license. As you can see, I've been assigned a license, and now I'm clear to get started. Let's go over to the Content tab to get started loading the imagery. Once in the Contact tab, all I need to do is click New Item and select Imagery Layer. For this imagery service, I want to create a tiled imagery layer. Once that loads up, I'll click on Tiled Imagery Layer and then click Next. I just have one image, so I'll select this option, click Next, and browse my drive to find the files I need for this TIFF image. Keep in mind, ArcGIS Image, we support over 30 different raster formats. Now that it's in here, I can already see that some progress is being made on the image. Now I can click Next once that's done to create the tiled imagery layer. I'll add a name for the layer, then some tags so it makes it easy to find within my online organization. And then after that, a brief summary, and just click Create. Depending on the type and amount of imagery you're uploading, it may take some time to fully create the tiled imagery layer. And that's it. It's as simple as that to upload imagery into ArcGIS Image for ArcGIS Online. So how do you get started with ArcGIS Image Online? Fortunately, because it's a SaaS offering, there's nothing to set up or install. All you need to do is license ArcGIS Image capabilities for the users in your organization. If you have any questions or like to go more in depth into the information about ArcGIS Image, feel free to contact us. We'll be glad to help you with a more in-depth overview. And now I'm going to hand it over to Nicole so she can talk about the wealth of imagery information within ArcGIS Living Atlas of the World and a little bit about GeoAI. Nicole?
Thanks, Chase. In this portion of our presentation, I'd like to provide you with a brief overview of the world's foremost collection of geographic information. Some of you listening today may remember when the Living Atlas was in its infancy in around 2007. And like any living thing, it has really grown and evolved over the past 14 years. I know I used to think about the Living Atlas as a place to find and utilize pre-joined census data or other vector resources like state and county boundaries. But did you know there are hundreds of imagery data sets too? These include a wide variety of high-resolution, responsive base maps, as well as pre-processed true color imagery, elevation data sets, and other multidimensional imagery services. Here are just a few examples. As a state or local government employee, world imagery may not be the first thing that comes to mind, but I like to think of these resources as one less thing to manage on my server. For example, if I were working for a state environmental agency, I could use a global imagery layer from the UN Environment Program that depicts biomass, and I could summarize all the raster cells within each of my state's watershed boundaries. Just because the data set is global doesn't mean you can't use it for your own area of interest. World terrain data is another excellent resource that you can use to easily add, say, hillshade to your visualization, aspect to your solar panel site suitability selection, or slope for your stormwater runoff analysis. All sectors of government need terrain data at some point. Scaling down to a national level, the National Agriculture Imagery Program, or NAIP, is a commonly used data set made available by the USDA Farm Services Agency. This program acquires aerial imagery during the agricultural growing seasons in the continental US, and with new data available every other year, it's really ideal for evaluations of land use, land cover classification change over time. Some of the world's most recognizable satellite programs, such as Landsat, are fully archived from the past 40 years and available in the Living Atlas. Emergency mitigation specialists might look at the vegetation scour from a dam break or the extent of a historic flooding event. This temporal perspective offers great advantage to state and local government GIS staff who need not manage all that unwieldy large data sets themselves to benefit from it. And last but not least, the Sentinel-2 mission offers continuity of multispectral imagery provided by older satellite programs like Landsat by continuing to offer high-resolution multispectral images that have a pretty high revisit frequency of about 5 days. It's ideal observation for the next generation of operational products, such as land cover maps, land change detection maps, and geophysical variables. So in fact, let's connect to the Living Atlas in ArcGIS Pro and use some Sentinel imagery to examine the change of the Land Between the Lakes National Recreation Area, which is just northeast of Mayfield, Kentucky, after last week's devastating tornadoes. In Pro's catalog pane, under the Portal tab, I've selected the Living Atlas and searched for Sentinel. I'll add this first result to the map. If I check out its properties and the metadata tab in particular, I can see that by default, it is displayed with the most recent and cloud-free imagery on top. Processing templates are raster function templates that have been published along with the image data to allow you to quickly apply that processing to the service in real time. Using Image Server, you can also publish your own imagery with processing templates. But those imagery layers in the Living Atlas that are already published with them are analysis ready, meaning you can get started easily. With the Sentinel data selected in my contents pane, I can use the Image Service layer ribbon to explore the individual images within this display extent and within a certain acquisition date range. I noticed there won't be any issues with cloud cover from Monday's pass over this area, so I'm going to add this to the map and rename it post-tornado. Let's also search for an image from before Friday's tornadic event, in particular finding one again with minimal cloud cover. And we'll add that to the map as well and call it pre-tornado. What you're seeing right now, the three red rectangles, represent human observations of the tornado. And so to kind of connect those dots in this uninhabited recreation area, we can use the swipe tool to go back and forth between before the storm and swipe to see the resulting vegetation damage, which really perfectly connects those two human observations. With these two images now stored in the memory of my Pro project, I can even use them as inputs to geoprocessing tools. For example, I could calculate the decrease in NDVI by subtracting one image from the other. Finally, let's take a look at how you can navigate the Living Atlas, not just in Pro, but in a browser window. I can scroll through and leisurely browse, taking note of what's new or the status of live feeds, or I can enter a specific search term. So let's again search for Sentinel, and I'm presented with imagery layers, ready-made maps, and apps. I can narrow it down by content type, date of publication, or area of the world. And I can even filter based on specific contributor flags. Now let's look at the whole imagery category. It includes multispectral and temporal imagery, base map imagery, and event-specific imagery, such as in the aftermath of a disaster. You may be noticing that my content results are in multiple different languages, and that's truly indicative of the global reach of the Living Atlas. In fact, the Living Atlas of the world only grows with contributions from around the world. So if you'd like to learn how to contribute your own imagery, check out the Contribute tab to get started. Finally, let's search for some special tools that can leverage imagery datasets. Deep learning packages are ready to use pre-trained models for object detection and classification. Here are a bunch of them, and it's a perfect transition into my next topic. All right, so far we know that the Living Atlas can provide both imagery, not only the ones I named, but many more sources, as well as tools. But how can they be used to automate workflows in state and local government? That's the topic of this next section, but let's start with some background and terms first. Artificial intelligence is the idea of achieving human-level intelligence with computers. It's kind of the overarching umbrella. Machine learning is a field within AI that's about learning from data to derive rules and extract patterns. And deep learning is one type of machine learning that is becoming very good at extracting patterns from highly unstructured data, like images. Usually when GIS people say AI, they really are referencing machine learning. There are 5 major patterns in machine learning, and the one we're going to focus on today is extracting features from LiDAR and imagery. The imagery deep learning tools in ArcGIS enable end-to-end workflows. So they can help with everything from managing and storing and pre-processing the imagery, as Chase discussed, and they can also help with data labeling, which is needed if you want to train deep learning models for object detection. The advantage of doing this in ArcGIS is that your work doesn't have to stop there. You can use different spatial analytics on top of the output from models to derive insights and answer additional questions. And then, like Chase suggested, you can share them in maps, apps, and a wide range of dashboards and other information products to disseminate that information and share it with others. This could be done for a wide range of data types, from aerial imagery, satellite imagery, radar, LiDAR, motion imagery, bathymetry, and more. Here are a few examples for projects Esri has been working on with state and local government customers, like detecting damaged structures and roads in public safety scenarios. This has been helpful when responding to disasters to understand the impact and extent of damage and prioritize rescue operations. We can see that the automation of map production is a major theme here as well. Examples include detecting building footprints, land cover, and road segments. All of these are examples of automatically extracting features from imagery to build or update vector maps rather than having to digitize those features by hand. If you're thinking, I've been doing some of this work for over a decade, you're not wrong. The GIS and computer science communities only recently started acknowledging some of these types of digital image processing as true machine learning. Finally, to bring it full circle, the ready-to-use models on the ArcGIS Living Atlas can save you a lot of time. Instead of preparing training data and training models from scratch, you can include these ready-to-use models in your workflows. They are well-trained for different data sets or scenarios and even countries, but you can also retrain the models with more localized data if needed to increase the accuracy in your particular workflow. The ArcGIS Living Atlas has lots of models, from identifying building footprints and road segments to human settlements, swimming pools, and even solar panels. And you can use these models in ArcGIS Pro, in ArcGIS Online, or within ArcGIS Enterprise. So let's take an example using ArcGIS Pro. This time I've brought in some customer imagery. It's a 6-inch image service from Kentucky from Above. Let's imagine this neighborhood is an area of new construction and I need to create building footprints to add to my countywide layer. I can use the Image Analyst extension and the Deep Learning Toolbox to detect objects. And the only inputs I am responsible for are my raster dataset, a name for my output, and a model definition. So this is where the Living Atlas comes in. Here are all of the pre-trained model definitions, and as you can see, there are many to choose from. Everything from detecting cars, pools, solar panels, tree points, roads, etc. In the interest of time, I'll just show you the results. These inferenced buildings in pale purple are a little soft and squishy and irregular. So I can then improve those using the regularized building footprint tool in Pro to give them more rectangular angles. Let's turn on that layer with the building footprints and see the results. There's such a wide variety of deep learning applications in state and local government that we invite you to check out the Living Atlas. You can search for DLPK and check out all these pre-trained models and let us know your ideas for applying them. To wrap up today's webinar with a discussion of how to collect and process your own imagery with the help of not a plane, not a satellite, but a drone, I'll turn things back over to Chase to tell us about SiteScan for ArcGIS.
Thanks, Nicole. For our last section, like Nicole said, we're going to talk about how to take imagery, particularly drone imagery, and turn it into an information product. Some of this may be a little bit of recap from the August State and Local Connect, but we do have some pretty awesome updates, including getting vegetation health indices from a simple RGB drone camera without the need for NVDI or near-infrared cameras. SiteScan can take plain drone photos and turn them into these type of information products: orthomosaics, digital elevation models, 3D point clouds and meshes, oriented oblique imagery, as well as thermal orthomosaics if you have a thermal camera, high resolution 360-degree panoramic photos, all with just a few clicks. Let's take a glance at this whole end-to-end conversion process and what it entails. When we talk about the end-to-end process of conversion of drone imagery into information products, the workflow can be broken down into 3 simple steps. First is the plan and capture step. This is performed by the SiteScan flight planning app. Using this app, user can quickly create a flight plan that's relevant to the type, site, or asset being captured. The iPad connects directly to most commonly used drones and sends the flight plans to the drone's autopilot for execution. After the flight completes, images are then transferred over the iPad and uploaded to the cloud via mobile or Wi-Fi connection. Step 2, images are processed in the cloud and the data outputs are generated. Within a few clicks, we're able to complete the processing, and once it's done, the user will get an email letting them know. You're not tying up a computer for a long time, and as soon as you get the email, your results are available to be viewed in the web browser. In the web app, users can not only view the data, but also perform some analysis, measuring both 2D and 3D, do volumetric calculations, view PDF inspection reports, or analyze change detection right in the browser. For the third and final step, dissemination, and collaboration. For those advanced analysis or workflows that can't be done within the browser, it's easy to either download the files locally to a computer or publish the datasets directly to ArcGIS Online or your enterprise portal. And also, to help your organization leverage its existing investment into Autodesk, you have an Autodesk workflow connector to publish directly to the BIM 360 Cloud from SiteScan, and/or you can use the ArcGIS Autodesk connectors. Now let's look at step 1, plan and capture, a little more in depth. Planning a flight with a flight planning app couldn't be simpler. The interface is very intuitive and user-friendly. And instead of talking about all of it, I'm just going to hop into a demo and show you it in action. Inside the site scanning flight planner app, we can quickly define an area we want to capture. This time it's a dam in Southern California. We can quickly determine the flight height and stretch the polygon to encompass the area we want to capture. Enabling terrain follow lets you see the flight in 3D and compare it against Esri's world terrain dataset, and also compare it against any 3D data you may have locally. When altering specifications of the flight, the bottom of the screen updates dynamically with the number of images, resolution, and estimated batteries. Doing one final inspection to check for obstruction, you can save the flight to be used later and open once you get on site. Once on site, you can load your saved flight plan, do a final analysis, look for any obstructions or issues, perform your safety checks, and let the drone start doing what the drone does. Once in the air, the drone will perform the complete mission, returning if it needs a battery change, and ultimately, once it's done, return to its takeoff spot once it's finished capturing all the images you've assigned it to. Now that it's landed, we can start beginning step 2 by uploading the imagery via SD card reader or to SiteScan Manager wirelessly for step 2 of conversion of the imagery into information products. Now that we've completed the data capture, we're going to discuss Process Manage and Analyze, which takes place in SiteScan Manager Cloud. SiteScan Manager is a web application that gives the user complete control over the data that was collected by the drone. It provides an easy way to access all the projects so teams can visualize and analyze the data in one centralized location. One of the benefits of this cloud-based application is that everything's immediately available across your entire organization. No need to download massive files. We've designed SiteScan Manager to be accessible to all your team members, even the less tech-savvy ones. The web interface offers 2D and 3D viewers and a variety of analysis tools that allow your teams to perform a majority of the common tasks one would want to do with drone data. Overlays, measurements, reports, annotations, or sharing with colleagues all can be done with little or no training at all. Now let's take a look at the information products you can create from simple drone photos by looking inside of the SiteScan Manager application. Here inside of SiteScan Manager, I'm going to open up a flight I did back in 2018 of a rock quarry in Southwest Missouri. Upon opening the project, you can quickly see the orthomosaic that's been generated from the 642 individual images the drone captured in order to create these information products. Up here on the left, you can also see the point cloud and 3D mesh that were created. The point cloud renders really fast over the web, and so does the 3D mesh. These visualizations help your organization see information from a totally new perspective, bringing a fully immersive experience into an image capture area that was just flat photos. Now let's take a look at one of the newest tools from the December update, the VARI, or Visible Atmospheric Resistance Index, to help emphasize vegetation across the mapped area by only using visual spectrum bands captured by standard RGB cameras, with no need for near infrared or NVDI. Now let's check out the elevation data tab. As you can see, contours are quickly accessible. The interval rates are changeable to whatever you see fit and whatever color you want. We'll change it to 1 in 10, and when you zoom in, you can see that the contour values are populated. These are very easily exportable product that's also created. Now, let's go ahead and just do a quick volume calculation, showing some of the analysis tools. By clicking on the toolbar on the right, you can click on the volume tool and quickly draw a polygon around anything in the capture area and immediately get a volume calculation. When you finish this, you can immediately see cut and fill, volume information. You can also view this information in 3D. Choosing a comparison surface to make your observation. This can be something you captured with the drone or something you've uploaded to show what it looks like now to what it maybe should be according to like a CAD or a site drawing. This is just a few of the tools that you can leverage inside of SiteScan. So now let's talk about the last step of the drone data workflow, disseminate and collaborate. Your team can, of course, simply download the outputs for local use on their preferred CAD system or in other analysis tools, but you can also conduct advanced analysis of your data by leveraging the ArcGIS platform, ArcGIS Pro Desktop. Applications like that, where you can use the AI detection like Nicole talked about from Living Atlas. Performing these analyses, you can also push them out through custom web apps, dashboards, through the Esri suite of field applications, and even through Autodesk. So I think that you can see that now creating information products from imagery is easier than ever. And with that, I'd like to thank you guys for attending, and don't forget to join us on our next up and coming State and Local Connect on January 19th. I'm going to turn it over to Shannon and we can do a little bit of Q&A.
Perfect. Thanks, Chase and Nicole. So I'm monitoring the questions here. And while I'm going to ask a few of the first ones, if everyone has any questions, feel free to keep entering them in, and we'll see if we can have time to get to them. So the first one, Chase, I'll stick with you, is on SiteScan. So does SiteScan for ArcGIS consume storage credits?
No, actually it doesn't. When you purchase SiteScan by the user type, there's actually unlimited storage, hosting, and analytics in the cloud. So, and what I mean by user type, there's a couple different types of user types that you can buy, but if you buy it in that methodology, it is unlimited storage, hosting, and analytics in the cloud.
And there was a question while you were demoing SiteScan about the difference between SiteScan and drone to map.
Okay, so SiteScan is a cloud-based processing platform. So it's in the cloud, and you also have the ability to manage your fleet information. It's a centralized location where all your flights get stored, and it's a way that you can do your analysis together as a group. Drone to map has its place for off-network processing. So you can process on your machine in your environment. You have to figure out how you want to store it and stuff, but we've had quite a few use cases where people want to actually process in a disconnected environment, and that's why we still have drone to map. It can still create these information products. It just doesn't have the interface to store and do the analysis.
Perfect. Another question on ArcGIS Image, how is it licensed?
So ArcGIS Image is licensed as an add-on. It's an addition to a creator named user in ArcGIS Online. So you just request the additional add-on. If someone has a creator named user already, you can give them the capabilities to use ArcGIS Image. But Perfect. You'd have to request a creator named user to start with.
And Nicole, are you with us? There's a question here on GeoAI. So it says, do I need any special licensing to use the pre-trained deep learning models?
I'm here. Okay, so you'll need ArcGIS Pro and the image analyst license, and that's the hard part. You'll also need to go to GitHub to download and install the free deep learning libraries for Pro. It's a really easy install. And then in my example, when I use that regularized building footprint tool, that was also coming from the 3D analyst toolbox. So I needed that 3D analyst license as well.
Perfect. All right, and I think we've gotten through most of them. Some of them are a little specific for each jurisdiction, so we'll reach out and answer some of those questions that we missed. But in the interest of time, we just kind of wanted to end on this slide. We do come every month back for this series. We're always the third Wednesday of each month. And next January, can't believe it's 2022 already, we'll be talking about ArcGIS solutions and what's new and what's ahead. So ArcGIS solutions are a suite of apps and templates that are free for all ArcGIS users. So we'll be covering and hearing from that team on what's new and what's coming. So please go ahead and register for that one at that link there. With that, I want to thank Chase and Nicole. Thank you everyone for spending 45 minutes with us, and we appreciate your time today. Thank you, everyone.